All right, I will be going over some examples of how to solve logs. And we want to make sure we understand the properties of logs because we'll have to use some, and also how to rewrite in exponential form. If you're not familiar, go back and watch one of my videos that talked about, well, just the one that says intro to logs. The first thing you want to look for is how many logs do you see on either side of the equal sign. If I just see one log, at some point I know that I'm going to have to rewrite this. And since it's currently a log, then I'm going to rewrite it in exponential form. So when I'm writing in exponential form, that means the log disappears, the actual abbreviation. So this is what it will look like. The first thing you want to do is you want to move your constant on the opposite side of the equal sign, which will leave you with log base 8 minus 8k equals to -1. So at this point, I can go ahead and rewrite. Well, you have to recall that when you're rewriting, you take your base of the log, you go to the opposite side of the equal sign, and then you come right back to that value. And now when I rewrite in exponential form, I get rid of the word or abbreviation log, and I am going to have 8 to the -1 power is equal to -8k. Solve for k, and that means I'm going to divide both sides by -8. And I am going to write, I'm just going to flip it around. K is equal to, at this point, you should understand how a negative exponent will affect the value or the base that's in front of it. If you don't, just basically understand that if you ever see a negative exponent, you're going to place a 1 in your numerator and you're going to take your base and you're going to move it down to the denominator. Well, moving that 8 down to the denominator, I also have something that's already in the denominator, that -8. And then if I did that, if I put them next to each other, that indicates that I'm going to multiply. So k is actually -1/64. That is my answer for this example. Now, when you're solving, you should always take your answer and substitute it back in for the variable k in this instance. And once you simplify it, it should end up being what they said it would equal on the opposite side of the equation. On the last example, I'm going to show you how to do it in the calculator. If you have a problem that looks like this, then it's great because now you have a one-to-one log base, well, a log that's showing on the left-hand side and the right-hand side one time. So if it's one time each, then what, and they look exactly the same, all you have to do is just get rid of it. And then you just bring down the value that's left over. So that will leave me with 4x plus 8 is equal to -x plus 3. At this point, you're simply solving for x. So I want to move my x over to the left-hand side, and I want to take my constant and do the inverse and move it over to the right-hand side. When I do that, I'm getting rid of the constants on one side and the variables on the other side. And simplified, I have 5x is equal to -5. Divide both sides by 5, and my x value is -1. And again, you can substitute that information back in to where you have your x's in your original problem, and it will balance out unless it's an extraneous solution. So you always want to check that. And for the sake of time, I'm not checking it, but I will show you that in the last example. Okay, so for this one, I see that I have one log on the right-hand side, but I have two logs on the left-hand side. So I can't just get rid of them. I have to get it to a point where I have one log on one side and one log on the other side. So that's where my properties come into play. Since there is a negative sign in between two logs, I have to recall that I'm using the quotient property. And again, I have a video on that, the property of logs, that you can go back and refresh your memory on. So I'm basically, what I'm doing is I'm just condensing at this point. So I'm going to condense this, meaning instead of having two logs, I'm just going to have one log. So log base 4. And the subtraction sign tells me that I'm going to divide my values. So I have an x minus 5 divided by 9, and it's set equal to log base 4 of 15. Now, at this point, I have one log on the left-hand side and one log on the right-hand side. So I can go ahead and use that property that a few minutes ago that I just used to get rid of them. Bring down what I have left over, which again is x minus 5 over 9 is equal to 15. If you ever have a fraction equal to a whole number, just make that whole number a fraction. And at this point, I personally would just cross multiply. So when I cross multiply, I have x minus 5 is equal to 135. And then solving for x, I'm going to add 5 on both sides. And my x value becomes 140. So that's solving for x. And again, you would take this information and you would substitute it in. Once you complete all of your, once you simplify it, you will end up with, it will balance on both sides. All right, so this is the example. I'm going to actually show you how to check and then substitute your answer back in and check in the calculator to see that it does in fact balance. Now, in this equation, I have 2 logs on one side, but I don't have a log on the other side. So again, the first thing that I'm going to do is try to get it to a point where I have just one log. So in order to do that, I want to go to my properties, which has a plus sign, which means I'm going to use the product property. And at some point, well, right now, I'm going to go ahead and condense the logs. Doing that means I'm only going to see the word log or the abbreviation log one time. And then again, product property means that I'm going to multiply those values. So I'm going to have 6 times 2x is equal to 1. So this is really simplified. Log base 9 of 12x is equal to 1. And remember, I said once you have a log by itself, just one log on one side of the equation, that means it's going to go in exponential form. So I'm going to drop the word log. I'm going to bring down my base, and then I'm going to raise it to the power of 1, set it equal to 12x. Now I want to divide both sides by 12 because I'm trying to solve for x. And 9 to the first power is simply 9, so I should have rewrote that, but I can also simplify this. And when I simplify, I can divide both the numerator and the denominator by 3, which leaves me with 3/4. So x is in fact 3/4. And just for those people like me who like to have their variable on the left-hand side, I'll just rewrite it this way. And as I told you a few minutes ago, I was going to show you what it would look like if you were to substitute it back into a calculator. So I would take my original problem and substitute it in. And you will notice on my second log here, I have the 2. And instead of putting x, I have 3 over 4, which was my x and my answer. And once I pressed equal, it said 1, which is what the problem told me that it should say. So that's how you can check for extraneous solutions. If you like this video or if it was helpful at all, please make sure you hit like and subscribe. Have a great one.